everybody. Today we're going to look at lesson 4, which is determining points and intercepts. So the first part of this is we're going to decide if a point is on a graph, if it falls on the graph, without actually graphing it. So basically what you're going to do, I want you to think about the fact that if I give you a point, the first number is your x, the second number is your y. So whatever those two numbers are, you're going to substitute them in for x and y into the equation. If it makes the equation true, so both sides are equal, then the point is on the graph. If it makes an equation false, so one side is not equal to the other, then the point is not on the graph. All right, so let's take a look. So it says determine algebraically. That just means using algebra, not a graph. So using the equation and using, your different operations. We're going to figure out if negative 7, 2, there's our x, there's our y, falls on the line whose equation is this. So rather than take the time to solve this, which we haven't done yet, and graph, you can just easily take the equation and wherever you see an x, you're going to plug in negative 7. And wherever you see a y, you're going to plug in 2. So instead of 5 times y, I'm going to do 5 times 2 minus 8. If that's equal to 2 times x, your x is negative 7, so 2 times negative 7. If they're equal, then yes, the point's on the line. If they're not, then it's not on the line. So again, it does help if you write x and y over these so you know, okay, wherever I see an x, I put my negative 7 in. Wherever I see a y, I put 2 in. Okay? So now I can easily figure this out. 10 minus 8 is 2. If you're not sure, quickly use your calculator. Second quit. 5 times 2 minus 8. 2. You want to see if it's equal to 2 times negative 7? That's negative 14. Is that a true statement? No, 2 doesn't equal negative 14. And that's how you explain your work. So is the point on the line? No. So not only do you need to write yes or no, but show me why, okay? All right, determine algebraically if the point 20, 0 falls on the line whose equation is x minus 2y equals 20. So x minus 2y equals 20. We're going to take out our x and y. Where I see my x, I'm going to put a 20. Where I see my y, I'm going to put a 0. And see if we get a true or false statement. So x, instead of x, it's going to be 20 minus, instead of 2 times y, 2 times 0. And again, you can type this whole thing in, but basically 2 times 0 is 0, and 20 minus 0 is 20. But again, if you're not sure, you don't want to just cross the 0 out and say, oh, that's 18. All right, let the calculator do the work. Let the calculator check your work. Notice how I'm typing it in, just like I wrote it. 20 minus 2 times 0, 20. This side's already 20. Since they're equal, yes, the point does fall on the line. All right. The second part of this is determining intercepts. So basically, an intercept, we've talked a lot about the y-intercept. It's where your function's going to cross the y-axis. Well, we're also going to talk about the x-intercept, or zeros, roots. So if you see a line or any function, here's your y-intercept, here's your x-intercept. Now, at the y-intercept, your x value is 0. At the x-intercept, your y value is 0. So to do this algebraically, without a graph, substitute 0 into the opposite letter of the intercept you're trying to find. So if you're looking for the x-intercept, you're going to plug 0 in for y. If you're looking for the y-intercept, we'll plug 0 in for x and solve. And then we'll write it as a coordinate point. So it'll be either 0 and some number or some number and 0. Okay, so let's do a couple examples. Determine the x and y intercept for the linear function. So again, I'm going to kind of separate this. If I want to figure out the x-intercept, I'm going to set y equal to 0. If I'm going to find the y-intercept, I'm going to plug 0 in for x. So let's look at our equation. 2y plus 43 equals 5x. So 2y plus 43 equals 5x. If I want to figure out the x-intercept where it crosses the x-axis, I'm going to plug 0 in for my y value. So I'm going to take this 0 and plug it in here. Because again, when it's crossing the x-axis, that y value is 0. It has a height of 0. Now it's similar to what we just did. The only thing is, instead of checking to see if they're equal, you have a little equation you're going to solve. Now 2 times 0 plus 43, that would just be 43. Again, if you're not sure, in your calculator, 2 times 0 plus 43. Use the calculator. I know sometimes we just don't feel like it, but take the time. All right, now to get x by itself, since I'm multiplying by 5, I'm going to divide both sides by 5. It's going to be a decimal, so it'd be hard to tell on the graph. 43, so we can just hit divided by 5. 8.6 is your x value. Now it did say to write as a coordinate point. So your x, remember every point is an xy. So your x is 8.6 and our y was 0. Okay? Now, if you want to find the y-intercept, you're going to do the same thing, but instead of plugging 0 in for y, we'll plug it in for x. So we have 2y plus 43 equals, instead of 5 times x, we're going to do 5 times 0. So we have 2y plus 43 equals 5 times 0, which is 0. Now you have a little equation to solve. Get y by itself. So we'll subtract 43 from both sides. 2y equals negative 43. Divide both sides by 2. Again, it's called algebraically because we're using algebra. We're using our equations. So negative 43 divided by 2. Negative 21.5. So you have your y value, you have your x value. Basically, that's where it's hitting down here. So that would be the point 0, negative 21.5. Okay? So if you put them both together, it would hit down here, be a line that looks something like that. All right, let's do one more and then actually see how we can use it to graph. I personally would graph this one using slope and y-intercept, but we'll see how we can use intercepts instead. All right, so here's our equation. Wants us to find the x and y-intercept. So if I'm looking for the x-intercept, again, we're going to plug 0 in for y. All right, so y equals negative 2x plus 6 is our equation. Instead of y equals, we'll do 0 equals negative 2x plus 6. And then solve it. If you don't like the 0 over here, put it at the end. But either way, I'm going to have to subtract 6. So negative 6 equals negative 2x. Divide by negative 2, and you get positive 3 as your x. So that means it's hitting the x-axis at 3. So here's your x-axis. It's hitting it at positive 3. That's the point positive 3, 0. Now let's figure out the y-intercept. I personally don't like to use this method. I think it takes a lot longer, but I do want to make sure I show it to you because you'll see it in geometry next year too. All right, so we have the same equation. This time you're looking to see where it crosses the y. So we're going to take 0 and plug it in for x. So y equals negative 2 times 0 plus 6. 0 plus 6 is just 6. Again, you could type it right into the calculator. Doesn't take any time at all. And you get 6. All right, so that means that's your y-intercept. It's the point 0.06. So find 6 on the y-axis. That's what a y-intercept is. 2, 4, 6 up here. And then you can take a straight edge or a ruler and connect the points. I don't have one on here, so I'm going to try and freehand it. But basically, there's that line. Right? You can use your intercepts to find out what the line looks like, and you should always label it. Now, for me, I wouldn't have done that. I would have said, okay, my y-intercept is 6, so I'd start right here, and then I'd go down 2, over 1, there's a point. Down 2, over 1, there's a point. Down 2, over 1, and you'd get your point that way. All right? Or you'd get your line that way. But that's just another method for it. And we'll talk more about that coming up. All right, so you have some practice on page 15, I believe, 15 and 16. Nope, just page 15. So give that practice a try, and I'll assign it in the next, and as a Kami assignment, so that way if you want to write on it, you can, or just do it in your packet and send me a picture. I'll also post the key if you have any questions, or you can stop and see me in the math lab. Have a great day.